Welcome back to Code Wonka channel. Today we will be solving lead code problem 238, product of array except self. Let's go over the question. Given an integer array nums, return an array answer such that answer of I is equal to the product of all elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time without using division operation. Let's take this example test case to understand the problem better, where nums array is 3, 2, 4, 1. The expected output array will be 8, 12, 6 and 24. Next, let's look at the explanation of the expected output. So for current element in nums array, which is 3, all the right of the current element is colored in light purple. The first element of output array is 8 because when we select all the elements in the nums input array except the current element 3 and then we multiply them, then the output is 8. Similarly, when the current element in nums array is 2, all the right of current element 2 is colored in light purple, or left of current element 2 is colored in light yellow color. The second element of the output array is 12 because when we select all the elements in the nums array except the current element 2 and then we multiply them, then the output is 12. Similarly, when current element is 4, then output of product of array except self will be 6. Similarly, when current element is 1, then the output of product of array except self will be 24. Let's think about a solution. On the left side, we have nums arrays with different current elements selected, and right of it we have their product of array except self. The left side of selected element are colored in light yellow, and right side of the selected element are colored in light purple. Now looking at the nums array with different element as current and the product of array except self, we can draw some observations that will help develop intuition to solve the problem in O of n time. Observation 1. Output array is product of elements of input arrays prefix product and input arrays suffix product. Prefix product till current index for all elements in input array can be calculated in O of n time and stored in array. The portions of the input array with different current index colored in yellow and highlighted in red are elements contributing to the prefix product till the current index element. Observation 3. Suffix product from current index for all elements in input array can be calculated in O of n time. It is similar to calculating prefix product when traversed input array in reverse order. The portion of the input array with different current index colored in light purple and highlighted in green are elements contributing to the suffix product from the current index element. From this we can draw this intuition to have first pass on input array to calculate the prefix product for all elements and store it in array. Have a second pass on the input array in reverse order to calculate the suffix product for all the elements. Multiply the suffix product with prefix product of respective indices and store it in output array and return the output array. Let's visualize the solution we discussed. We will start with computing the prefix product of the array. We will start by first pass of the input array by initializing index pointer pointing to the first element 3. We will initialize the prefix product variable to empty array. Because current element does not have any prefix product, we will append 1 to the prefix product array. We increment the index pointer to index 1. Now prefix product is 3. So we can calculate the prefix product by selecting the last element of prefix product array and multiplying it with the element at index minus 1 of nums array whose value will be 3 and we append it to the prefix product array. We increment the index pointer to index 2. Now the prefix product is 3 into 2, which is 6. So we can calculate the prefix product by selecting the last element of prefix product array and multiplying it with the element at index -1, which will be 6, and we append it to the prefix product array. We increment the index pointer. Now the prefix product is 3 into 2 into 4, which is 24, and we append it to the array. Let's look at calculating the suffix product. We will have the suffix product array initialized to the size of the input array with empty elements. We will make the second pass on input array, but now in reverse order, starting from end element of the input array. Because this is the last element, it does not have any suffix product. So we will update the last element in suffix product array to 1. We will decrement the index pointer. Now the suffix product is 1. We can calculate the suffix product by selecting the index +1 element of input array and index +1 element of suffix product array and multiply them and update the value of element at current index of suffix product, which is 1. We decrement the index pointer. Now the suffix product is 1 into 4, which is 4. We can calculate this value by selecting the index +1 element of input array and index +1 element of the suffix product array and multiply them and update the value of element at current index of suffix product, which is 4. We decrement the index pointer by 1. Now the suffix product is 1 into 4 into 2, which is 8. We update the suffix product array element at index 0 to 8. Let's look at calculating the output array, which will initially be empty array. We take the first element of prefix product array and suffix product array, multiply them, which would be 1 into 8, which is 8, and append it to the output array. Similarly, we take the second element of both the arrays, multiply them, and add its value to the output array. Similarly, we append 6 to the output array. Similarly, we append 24 to the output array. So we got the expected output. Next, we will look at coding the solution. In the code, we won't actually use the 3 different arrays. We will use one array, prefix product, and have the output array values calculate in prefix product. For suffix product calculation, we don't actually need to store it in an array. We will have one variable which will store the suffix product of the current element and forget about all the previous values of the suffix product. This is to optimize space in the code. We use 3 different arrays in the solution visualization for better explanation and understanding. Let's code the solution up. We'll start by initializing the prefix product variable to an array with element 1. Next, we'll write a for loop for the first pass on nums array to calculate the prefix product for all the elements. Next, we'll append the prefix product till current element to the array. That will be nums of I-1 into prefix product of -1. Now, we will initialize the suffix product variable to 1. Then we'll write a for loop to calculate the suffix product for all elements. We iterate the input array in reverse order. Next, we will calculate the product of array except self. This will be multiplication of prefix product and suffix product of the current element. Now, we will update the product of array except self in prefix product array. Then we will update the suffix product for the next element, which would be suffix product into nums of I. Finally, we will return the prefix product. Let's submit the solution. It got accepted. The time complexity of the code is O of n because of the loops used to calculate prefix product and final output. The space complexity is O of n because of the storage used by prefix product variable. Please leave your feedback about this video in the comment section. If this video helped you in learning, then please subscribe to the channel and hit the like button. Thank you for watching this video and stay tuned.